So, functional package management, what's in it for me? And what is functional package management? Functional package management is a big lie. Are there any functional programmers in here? Do you do functional programming? Have you done any pure functional programming, like in Haskell or Elm? Okay, yeah, there's one there, sort of. So functional programming is a big lie, and why is that? It's because we pretend that we can call the same function over and over with the same data in, and it will always give us the same result back, and that's the only thing it will do. And we know that in a computer there's electrons running around, it's heating up the computer, that's a side effect. So it's not really true, but it's true enough, and it's useful. So what can these lies do for me? And I'm going to show you how functional package management is even more of a lie than functional programming, but it's still a useful lie and it's still true enough. And I'm going to try to explain how that is useful in this context that we're in now. So these slides are available because I'm going to skip over 90% of them, so you can follow the rest of them, and there's several links at the end that can teach you more about what Guix is and what Nix is and why they're useful. So, quick background. What's a package manager? A package manager allows me to take software in some form and make it so that I can use it on my system by just typing the command. The simplest possible package manager, but it's still more useful than some of the less simple package managers, is Stow. Stow was created by the GNU project, so it's a small project, it doesn't even have its own icon, so I just put the GNU icon in there. It was perfect in 1996 at version 1.3.2. Now it's at 2.2 point something. It was like dormant for 10 years and someone picked it up and improved it in ways I don't understand. I think they refactored the innards, they added more internationalization and things, but it's basically doing the same thing that it did 20 years ago. And what it does is, this is how you manage applications when it's not available in your system by default, or it's not in your normal package manager. You have to download it from somewhere, you have to configure it, you make install, and boom, it's available. And when you're not the administrator of your computer, you install it to your home account somehow. For example, in .local. But then you have a problem. This is getting ahead of things a bit. Yeah, you have a problem because you have versions of things. New version comes out, what are you going to do? Usually, you configure, you make install, and then you have the new version. Boom. What happened if the new version has fewer files than the old version? Usually there's no uninstall function, and usually that means you will have files lying around that belong to some old version because the install function didn't upgrade it. So what Stow does, it allows you to install to a more specific folder. Like, this is the folder for my application, and then Stow does magic symlinking. So it can identify that, okay, this is the new version, and then it looks around and it sees that, okay, we have symlinks here to files that don't exist in the new version, and then it can remove them. And what happens is, so we have the apps, your app, my app, and one of them uses some lib. And so we have different versions of these things, and they're all mixed together. So it's all in .local/bin, and I can run from there. But in reality, they're in various different folders, and that allows me to isolate them so I can remove one of them. And it's a simple operation. You change the name of the folder, or you remove a symlink somewhere, and then you can let Stow go through things and remove things. Yeah. So this is the question. If I have some app that depends on one version of a lib, and I have another app that depends on some other version of the same lib, I always have one global installation. This doesn't solve it, but these guys do. Because there's a problem here when I want to update that lib. Either I had a hard dependency directly into that special subfolder of that lib, and then I get the problem that I can't upgrade it because I have to recompile everything. Or I had my binaries point at some generic location, like into .local lib, And that means if I upgrade this, it will upgrade it for everyone. So what you can do in functional package management, yeah, here are the lies. There are no side effects. You only have data going in and data going out. Every time you do it, you get the same result. And that means the data that comes out, you can store it in an immutable data store. And immutable data is great. Functional programmers use it all the time. But in the end, if you have immutable data, you cannot do anything. So what you do is you have mutable references to the mutable data. And that's what's used in things like IPFS and BitTorrent and whatever, and in Git too. Like you have the Git store is immutable data, everything is hashed. But to be able to say that now there's a new commit out on master needs to be mutable, so it points to a new commit. And so this is what we do also in functional package management. So by having all these things that hard link to each other, like I have bash installed, and it's not just bash uses any old glibc, it uses exactly the glibc 2.5.3 that was compiled with GCC 5.3.5, and everything depends explicitly on a very specific package. Every package has a hash of the description of what inputs it had to be created. And this allows us to have a chain of dependencies, which can all be different for different versions of the same software or for different software that uses different versions of some other software. And this allows us to update some reference. And then we can see that, okay, we updated this reference over here. We have updated all our software. And then we can follow these dependency links. And we can see, oh, this version of glibc is not used anymore. And then we can garbage collect it. But that's not why we're here. This is all very technical. So I'm going to try to squeeze together some things about this. Let's see. Here we have how do you deploy a web app today? How do you deploy a client app? We talked about NPM and how NPM is awesome. What are there? Over 100,000 packages? 400,000 packages. That's amazing. In PyPy for Python, there's like 80,000 packages. And you just declare this file in your project, and boom, you get everything you need to run that software. People just need to clone your repo. They run npm install, and they get everything. Except they don't, because you might have a native dependency. So there are some native dependencies in there, but maybe not everything. And it's really a clumsy way to do it, because npm is not meant for native dependencies. So what we can solve with these systems is that we have one file that describes any kind of dependencies. It's an npm dependency, it's a native dependency, whatever. And then my software that I want you to use as a user, even if it's not in your Linux package manager, if you have Guix installed in parallel to your existing package manager, which you can do. I have Ubuntu running with Guix and Nix as parallel package managers. I can just clone your repo. I can go in and I do Nix shell, and it downloads everything, including binary dependencies. And this allows me to distribute my software in a very usable way. And so I think that can help us without being dependent on these Linux distributions to handle everything, including Nix and Guix. They are distributions, but you can also have your local definitions of these are the packages I need, and you can include that into the command that just downloads these. Instead of doing npm install, you do Nix shell, and you can have all the package definitions of things that are not in the official Nix distribution, just in your Git repo. And it can download and compile all of those. So that's really awesome. And I think it can help us distribute web apps. Things like Sandstorm could be built on Guix or Nix at the sort of lower level. Or they could be what they are today, but also add this functionality. And from the distributed point of view, this is, as long as you have the Guix Git repo, that's the description for building the whole Guix package distribution. So you can do everything yourself, but you seldom do that because that would take, it's like if you would install Gentoo without using the binary install. It would take you days to compile everything just to get the bash prompt. So what we do is we have a build server, which is centralized, that builds everything. You have to trust the key of that server. So when you do Guix package install something, it checks, does this hash already exist on the central build server, and then it downloads it. Now the decentralized point of this is, Matthias could run that server on his computer, and I could trust his key, and I could download this stuff. And there's work going on using GNU-net for distribution. So I don't have to rely on him having this heavy server that can allow thousands of people to download stuff. But instead, he could offer this over GNU-net or IPFS or some other distributed mechanism for distributing packages. And that could allow us to pull down things in a way that doesn't mean someone needs to foot a really strong centralized server bill. So that's about as much as I can compress it together. I've already gone over my time, but any questions? Yeah? Nix is the original. It was made in 2004. And Nix has a language that is a pure functional language. And let me say, oh, I have this one. Nix. Nix OS, Nix Package Manager. Here is a typical package in Nix. So there's some boilerplate, and then we say it has a name. We get stuff from somewhere. We double check that we got the right stuff and no one was man-in-the-middling us. And then it's the meta information, and that's it. This is a package. It's not so difficult if it's a normal package that just does configure, make, install. But this is a weird language. You go into this and, hey, what's this standard MK derivation? What's this? And what's this syntax? I changed something here, and now it complains about something I don't understand. And also, it's limited because it is its own language. If you want to extend this, you have to have people working on modifying and improving the language. So what Ludovic Cortés was thinking was, let's take an existing language that is very good at making small languages. And that is Scheme. So you have the same definition of hello world. And now it's full of parentheses, which you may or may not like. There are ways to express Scheme without all the parentheses. But when you have this, all of this now becomes a Scheme data structure, and you can use normal Scheme language to modify it. You put your definition in a normal Scheme file that is interpreted by the Guile interpreter, and you can write macros. You can take the way they distribute Python packages is first you define a Python 3 package, and you just run the macro, make this a Python 2 package, and boom, you have it. So that's what you can do when you have a real language, and you don't have to put effort into improving that language. You have to improve the DSL, but it's less effort. A lot of the stuff is taken care of for you. And now Guile 2.2 is coming out, and boom, your performance evaluating packages goes up 20 times because it's a better VM. I forgot your question. What's the difference between Guix and Nix? This is the difference. Yeah, it's the language. And having a different language here allowed them to innovate on, you can express services in a different way, so that I have this mail service, and now I have this web front end that needs to send mail, and it can get that parameter sent to it through magical means, which is more difficult to do in the Nix language. So Docker is about containerization, but also about handling all the binary dependencies. So you can go to any system and you can just run Docker and it solves everything for you. This can do it better, yes. Docker is not about reproducibility. This is about reproducibility. You have the Git repo of the Guix distribution. You know which commit you were using. You have all the instructions to create everything from scratch. If the build server goes away tomorrow, I can still take the description of my system and I can rebuild it from scratch. I need bootstrap binaries that are like, I don't know, a couple of megabytes. It cannot be turtles all the way. It has to be rooted somewhere. So somewhere in the bottom is a primitive bash, a glibc, and a guile, and then those are used to compile the real bash and glibc and guile and gcc and everything, and then it builds up from there. For some types of packages, they don't need a root because it's like, yeah, this is just a text file. That kind of package can live on its own. So yeah, this provides reusability, and you can use this instead of Docker, and you can use it for containerization if you want to, or you can not use it for containerization. You can use it to produce Docker images. You can use it when you are already using Docker and you have this limited Docker image that has nothing, it doesn't even have VI, and it's like, oh, now I need to go into an instance of this image and I need to troubleshoot it and I have no tools. You can just mount the /gnu directory into /gnu in that Docker image, and boom, you have everything you need. If I go to /gnu/store/ very long hash blah 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 vi, that's my vi right there, and all the dependencies are included in the /gnu directory. So that's how I use it at work. Actually, our build containers are very limited, but I have a function that allows me to go into the build container and bring all my tools with me, just to one mount or one directory. Thank you so much. Yeah.